Hi everyone. In this video, we're going to go over what we did in class today, talking about measures of center, looking at the center of a set of data and what that means for us. It's going to help you with classworks number 5, 6, and even 7 as we move through all of this information. So let's take a look at some data. Oops. Let's say I gave my students 5 exams. Okay, and I'm looking at the data of 3 of my students. Let's start over here with Anna. Now Anna, and I'm just going to make a little dot plot. Anna here scored a 70 on the first test. Then she scored 3 80s on the next 3 tests. And then she scored a 90 on the 5th test. So just by looking at this data, whether we look at the dot plot or whether we look at the data up here, we can see that the number 80 is right smack in the middle. There are 2 data points below 80 and there's 2 data points above 80. And if you look at the dot plot, you can see if you count 1, 2 on this side and 1 and 2 coming from the other side, you're left with this number right here in the middle. It's got the 2 datas on each side of it. So that's all the median is. It's that point where 50% of your data is above it and 50% of your data is below it. So it is really just a physical center of the data. Okay, now let's take a look at the mean. Now I know you all know how to find the mean. It's just the average, and you've probably learned that long ago that to find the average of a set of data, you take all that data, 70 plus 80 plus 80 plus 80 plus 90, you add them all up and you divide by 5, and if you do all of that on your calculator, you are going to discover that in fact the mean is exactly the same as the median in this data. So I'm going to circle the 80 in blue. Okay. Now, what I want you to do is, rather than actually circling a point, I'm going to draw a line here at 80 because sometimes the mean is not an actual number. So here's the mean in blue, and it's also 80. Okay, but rather than counting up the number of data points on either side of it, what we're going to do is we're going to add up the distance between that mean, that line, and all the data on each side of it. So for example, if the mean is right here at 80, then this test right here, the 90, is 10 points above that mean. It is 10 points above that mean. Now these next 2 tests, or all 3 of these tests, they're right on the mean, so they are not above or below the mean. Their distance from the mean is 0. They're at the mean. There's no distance above it. There's no points below it. Okay, and then this last test is actually 10 points below the mean. It's 10 points below, so we'll mark that as a negative. Now, what we're going to do is, here's our mean line right here, and if you add up all the distances on this side, which is plus 10, with all the distances on the other side, negative 10 plus a positive 10 is equal to 0, and that is the sign of your mean. It is a measure of sort of balance. It's where it's balanced, and the net result is 0 on both sides. Okay, so there's a slight difference between mean and median. They're both measures of center. They just measured a little differently. All right, let's go over here to Bo. Now Bo scored a 75 on the first test and then a 75 on another test. Then she scored an 80. Then she got a 90 and then 100. Okay. So if we look at this data, I'll do the median in yellow. Again, by looking at our raw data up here, we can see that again, the median is right smack in the middle with 2 data points below it and 2 data points above it. It doesn't matter the value of those points. It's just that center number. The median is again 80. Okay. Get my little eraser here and erase this 8. I mean to write that. Back to my pen. Okay. So again, the median is 80 for Bo. If we look at the actual dot plot, we can see that right here is 80, and we can see she's got 2 tests below it and 2 tests above it. So perfect 80. Okay, let's now take a look in blue at the mean. Well, if you take a minute and you do it on your calculator and you add up all these scores, the 75 plus 75 plus 80 plus 90 plus 100, divide that all by 5, you will discover that the mean of this set of data is 84. 84. Okay. Now 84 isn't even an exact test score for her, but it's 84 would lie right about here. So 84 would be right about here. And on our dot plot, 84 would be right here. And we're not going to write it as an X because it's not actually a test score, but we're going to mark it here. This is our mean line right here, mean. And it's an 84. Okay. So let's do some red. Okay. So let's think about this now in terms of balance. So mean is a little more work, but if the first test she got was a 90, or one of her test scores right here is at the 90, okay, we can see what is this distance from the mean out to the 90. Well, we can always do subtraction. 90 minus the mean, which was 84, is equal to 6. So this is 6 points above the mean. This test out here at 100 is 16 points. 100 minus that 84 is equal to a plus 16 points, and that was a plus 6. All right, and that's it. Those are the only 2 tests to the right of the mean. And if we add 6 to 16, we're going to get a total of plus 24. All right, what about on the other side? Well, this test here, which is the median, is an 80, and the mean is 84. We can see that 80 minus 84 is 4 below. It is minus 4 points below the mean. All right, how about this next test out here at 75? How far is 75 below the mean? Well, you can use your calculator if you need to, but 75 minus the mean of 84 is equal to -9. And there's 2 of those tests. There's 2 out here at 75. So we have 2 -9s, and then we also had that -4. And if you sum that up, -9 plus -9 plus -4, you're going to see that that is negative 22. And I made a mistake over here. 16 plus 6 is 22. Probably most of you already knew that and were screaming at me through the screen. Do those things on purpose to make sure you're paying attention. All right. So there you can see you've got positive 22 on one side of the mean, negative 22 on the other side, and therefore that mean is balanced. Right. So why in this problem is the mean bigger than the median, and over here the mean is the same as the median? Well, let's take a look at our data again. If I do a little look at the shape of this, for Anna, her data is very, and that wasn't very well drawn, but it's very symmetrically drawn. It is a normal distribution. The amount of data above and below is very evenly spread. Okay, but with Bo, what happened? She started out having a couple of low test scores, but then as time went on, she really got much stronger. So we can see that this data is skewed to the right. All right, these higher test scores are pulling the data that way, and they're pulling the mean. The median is static. That's really not going to move. That's always that middle test. Doesn't matter what these numbers are, whether they're high or low. It's just physically that middle number. But the mean is the average, so those weights are taken into account, and so that's what pulls that mean to the right. All right, so lastly, we'll take a quick look at Carlos here. Carlos earned a 60 on one of the tests, then a 70, then an 80, got an 85, and a 90. Okay, so again, you can see a pattern here. 80 is right smack in the middle. It doesn't matter what the values are. So our point here is 80 for the median. That doesn't change. And let's quickly do the mean. If you add up all those data points and divide by 5, you're going to discover that the mean is in fact 77. And so, and you can probably almost see that even though there's just one data point for each. You can kind of see that the data gets is pulled in this direction. It's a little more clustered right up in here. So we've got that mean of 80, and now we have a median of 80, and now we've got our median of 77. And so I'm going to mark that mean right here at 77. I'm going to use it as a line rather than a data point because he never actually got a test score of 77. But let's just check if it holds true. We can quickly do that. So 77, one of his tests was 80. 80 minus 77 is 3. One of his tests was an 85. 85 minus 77 is 8. And then the last score was 90. 90 minus 77 is equal to 13. And if we sum up 13 plus 8 plus 3, we are going to get a plus 24. So you guys can pause the video and just see if it works for you the other direction, and then come back and check. So from 77 down to 70, this direction, 70 minus 77 is that negative 7. Negative 7. And then from the mean, the 77, all the way out to the 60, 60 minus that 77, that is going to equal negative 17. And together, when you combine them, you get negative 24. So in fact, we got that balance. Okay. So that's just a little difference between mean and median. So just to summarize, guys, let's go to this last. To sort of summarize here, you want to think about the mean, or let's start with the median. The median is actually that physical center. It is that spot right here where no matter where your data is, there's the same actual numbers of data points. So if we have 1, 2, 3, 4, 5, 6 data points on this side, we have to have 6 data points on this side, no matter how they're spread out. No matter how they're spread out. So you can have sort of skewed data. We often look at the median when this data is skewed. All right. Skewedness does not affect that sort of middle number, whatever that may be. All right. But for the mean, it's more about balance. So what that means is wherever your data is, and you don't even have to have the same number. You could have only 2 tests on this side and 4 on the other side, and the mean could be here. It has nothing to do with the actual number of data points on either side. It has to do with the distances, so that this distance plus this distance is going to counterbalance with these distances. All right, so that it's this side plus the other side. Your x minus x will always equal 0. Those sums, these distances add up, so it's the distances. Okay, so that's a quick review of the difference between mean and median and how they're both measures of center. All right, so try that homework, that classwork 5, 6, and 7.